So 2.6, we're basically dealing with a lot of log properties in this one. So we're going to kind of just go through with several examples. So the first one here, we're going to expand. I am giving you log base 5 of 25AB. I'm going to walk you through this first one, then I'll let you try one. Can you guys see that okay, or is that a weird color? Are you okay, Asher? I know. You're good? Okay. All right. Logs, remember, are related to exponentials. They're the inverse of exponentials. So all of those exponent properties are related to our log properties. So when you're multiplying, like, you don't have to write this down. If I have like a cubed times a to the fourth, what is that?
A to the seventh.
Okay. So when we're multiplying with the same base, we add the exponents, right? Okay, so what we can do with logs, we'll keep the same base, so log base 5 of 25 plus log base 5 of A plus log base 5 of B. So you can expand anything that's multiplied together like that. Expand means write it out as multiple logs, either with addition or subtraction. Okay. Can I evaluate any of these? Yes. Which one? Yeah, what does that equal? 2. So your answer is actually 2 plus log base 5 of A plus log base 5 of B. Okay? We good? All right, you guys try one. Let's do log of 100 AC. So again, expand. Yeah. You're ready to answer for me?
Well, I am that, but
You
also,
are.
I was just going to ask log 5 of A if you could not combine that with log 5 of B or expand it.
Right. So the next part we're going to do is condense, where I'm going to give it to you like this, and you have to turn it back into a single log. So just ahead. All right, guys, let's look at it. Are you okay with that step? Yes? Yes. What does it simplify to? 2, yes. It's like shockingly similar to our first one, huh?
Well, you not just 10 for the log.
For the base? Nope. If there's no base written, we know it's base 10. That is your common log, yeah.
So what is this platitude?
So what we are thinking, log of 100, the base is not written, so the base is 10. I'm thinking 10 to what exponent is 100? So that's why it's 2. That's all you're doing. All right, so now let's try going the other way. You are going to condense. I'm sorry, yes, condense. Mixing up which one we're doing. So I'm going to give you log base B of A plus log base B of C plus log base 2 of X plus log base 2 of Y. Okay. So first, can I condense that all into a single log? No, I have to have 2 of them, right? So log base B, Sean, what's that going to be? Good. plus, what's the rest going to be? Okay, simple so far? All we've done is add, right? All we've done is add and multiply. So let's expand again, but now we will throw in some fractions. Let's do log base 3 of 27 over 2. So we're expanding. We're going to write it with multiple logs. Multiplication was addition, so what's division? Subtraction. And right, same with your exponent rules. If you were dividing, you subtract exponents. So I'm going to have log base 3 of 27 minus log base 3 of 2. And then evaluate the first one. 3. So this is just 3 minus log base 3 of 2. So far, so good. Not bad at all, right? Okay. We like it so far. Let's see. All right, let's try this. Natural log of 4 over 3e. You guys try this one. Expand for me. All right, I'm going to write 2 answers, and you have to tell me which one's right. Which one's right? How many vote for the first one? How many vote for the second one? Okay, the second one's actually right, guys. Okay. All right. Let's look at y. Sean was too scared to vote. It's okay. All right. Fine with that. And then, aren't I dividing by both of those? Right, the 3 and e, yes, they're multiplied together, but I'm dividing by both. Okay, so if you distribute your negative. Okay, you can also think of it as the coefficient is the exponent. So this is essentially 3 to the negative first. So that would be in the denominator. This is e to the negative first, which would be down here. And yes, we can simplify that. Is that where you were going? Yeah, okay. And what is natural log of e? Good. So natural log of 4 minus natural log of 3 minus 1. That is your actual answer. All right, so when you're expanding and condensing, anything from the denominator should have a negative coefficient. And when you're trying to put it back together, anything that's got a negative coefficient will end up in the denominator. Okay. All right, let's try another one. I don't know that you need this one, but we'll do one more of those. So natural log of 2x over 5y. Just expand for me. I like the enthusiasm today, Phil. You want to tell me your answer?
Yeah.
All right, go for it.
ln 2 plus ln x minus ln 5 minus ln 5.
Lovely. All right. We good? We're okay with the both negative parts there? Okay. We're just going to keep doing several expanding here. They're just going to look slightly different. Let's do log base 2 of 4 to the 6th.
Wait a second.
Where does the exponent go? In front. Right? Isn't this 6 log base 2 of 4? Yes. Okay. What is log base 2 of 4? 2. So this is 12. All right, other ways you could have gotten there. 2. Yes. Absolutely. You could have said, all right, 4 is really 2 squared. So that's really 2 to the 12th. Well, those are the same, so it must be 12. Okay. However your brain works, I'm good with it. You know, assuming it works. One way or another. Small detail there. All right, great. Let's try again. All right, ln of x squared over x plus 4. You guys try, and again, I'll write 2 answers. You tell me what's right. All right, how many vote for answer 1? How many vote for answer 2? Okay, some of you just aren't voting. Yeah, it is not the second one, guys. When you have like a quantity like that, x plus 4, something where there's addition or subtraction connecting your values, you cannot break that apart any further. It's only multiplication and division that we turn into addition and subtraction. Okay, so this is it. That's your final answer on that one. All right, so natural log of the quantity x minus 4 squared over x times x plus 5 cubed. Are you guys trying? You got it? Go for it, Sean.
2 ln x minus 4 minus ln x minus 3 ln x plus 5.
Beautiful. How do we do, guys? Not bad? Okay. All right. We're going to condense. So we're going to go back to going the other way here. All right, negative 3 ln of x, natural log of x, plus 2 natural log of x plus 1 minus 5 natural log of x minus 2 plus natural log of x plus 3. And you don't have to actually multiply things out at the end of this, okay? You just have to create a single natural log of something. All right, you can condense that all down to one thing. Check with your neighbor, see if you agree. You can like go over there.
Well, the other one is like x to the negative 3. That's what I
Think you got it, Aiden? Okay, let's see.
ln x plus 1 squared times x plus 3 divided by x to the 3rd times x minus 3.
Perfect. Yeah.
What is the x plus 1?
So it is this. So x plus 1 squared. We don't start with this because that's actually in the denominator because it's a negative
Oh,
up in front. I wrote it in an order to try to mess with you. Don't let me mess with you, okay? So guys, you see it? Anything with a negative and f as part of your denominator? Plus this was part of the numerator. Did you get it right? Got it? Yes? Yes? Okay. Wait a second. Make sure we're okay with that one. It's all just moving things around, numerator versus denominator. Dylan, you good? Yeah. Okay. Anybody questions on that before I move on? Okay, next one's going to look a little different. Let natural log of a equal 4, and the natural log, I'm sorry, I switched that. Natural log of 4 equal a. Wouldn't make sense the other way. And natural log of 5 equals b. What your directions would say is something along the lines of rewrite this as the sum or difference of like A and B, using only A's and B's in your answer. Okay, so I want to walk you through the first one and then I'll give you several to try. So the only numbers I know I can use are 4 and 5. Can I think of a way to make a 20 out of 4 and 5? 4 times 5, okay. All right, then I want to go ahead and expand this. So are we okay with this is natural log of 4 plus the natural log of 5? Okay. My very last step is to substitute in the a and the b. So what does natural log of 4 equal? And the natural log of 5. So a plus b is the answer. Please, please, please do not say, oh, here's a 4 and a 5. This must be an a and a b. And no, okay. Don't put your letters in until the very last step. You've expanded, you've done everything you're doing, then put your letters in. Okay. All right. That was a pretty easy one. I'll give you a couple others here. Let's try natural log of 100. Let's try natural log of 0.25. All right, we'll just do those two for right now. Guys, we're almost done with notes. It's a short note day.
Okay, and then simplify that.
Like if I had a plus a plus a. Messing with you with the decimal limit? You're like conspired. What if I tell you as long as letter C has
I have C minus 2. And C minus 2.
I know that that would be negative a.
I might be wrong.
I know.
What? I don't know.
I can't wait. Yeah, it is. I was trying to include B in there. Yeah, okay.
you made that four. C's not bad once you see it. I like it. So look, I mean, you should be able to get there the way you did it. But if you think about it, you'll understand that.
So you could do
I would do that probably with only yes. All right, guys, let's go through them. All right. So 100. That is 5 times 5 times 4, right? Okay. I want to go through a couple ways you can write this. You can absolutely tell me this. And oops, not that. And then b plus a. Please simplify that to 2b plus a. Beautiful. The other way you could have thought of it, you could have thought of it as 5 squared times 4. Right? And then that's 2 times natural log of 5 plus natural log of 4. So that is 2b plus a. I don't care. They both work. Does that make sense? You guys say, no, that makes no sense. It's okay. Go get that. All right, so are we okay with B? All right, C. A lot of you were trying to use the 5 in some way because you see 25 and you really want to do 5 squared. But it's not. It's 0.25, which is 1/4. Okay? Lots of different ways you can go from there. You could tell me natural log of 1 minus natural log of 4. What is natural log of 1? 0 minus natural log of 4, so what, negative a? You could have done 1/4 is 4 to the negative 1. So that's negative 1 times natural log of 4, which is negative a. Okay? It's recognizing the decimal as the fraction that is key. Alright. Questions? Get up there. You just didn't say 5.
I had to wait to see minus a.
And you didn't recognize that that was just negative a.
Yeah.
Yeah. Yeah. All right, are we okay with these? Where you substitute? One more really short thing to go over. It is called the change of base. If I have log base 8 of 5. All right, what change of base does is it allows us to evaluate this kind of, even if you have an old calculator. You can't figure out log base 8 of 5, like I don't just know the exponent that is log base 8 of 5. So you can use your calculator. A lot of you have newer calculators. We don't need to do it right now because you just don't need to actually evaluate it. You just need to understand the process. You guys, most of you can type in whatever base you want in your log. You used to not be able to do that. So the way you would key it in was you could say common log of 5 over common log of 8 or natural log of 5 over natural log of 8. That is how you can evaluate it. So let's do one that we actually know if you want to key it in. Let's do log base 2 of 8. What do you know that's going to equal? 3. So in case you don't trust me, log of 8 over log of 2 on your calculator or natural log of 8 over natural log of 2 in your calculator. See if you don't get 3 with both of those. Okay. An easy way to remember it, the base goes in the basement. Okay, so whatever the base is, that's the one that goes on the bottom. If this is on a non-calculator part of your test, I would just ask you to like set up the change of base for me, and that'd be all you have to do is write it.
Does it matter whether it's element or log?
Nope, as long as you're consistent numerator and denominator. The ratio ends up being the same with both of them. Okay? All right, question? Yeah, Ben.
Would that also just equal 8 over 2 or 8 over?
No, it does not. No. Because the log is an operator and you're essentially thinking of this as an exponent. Because log base 2 of 8 is actually 3. And it's 2 to what power is going to make 8? Like how do you turn 2 into 8 with an exponent? So you can't just cancel out the logs. Okay. Okay, everybody okay? All right, that's the end of notes. So we're gonna play a little game now. Have we done any, like the bluffing game? Have we done any?
Yeah, we did
We did the bluffing game? Okay. We're not playing Jeopardy. You see a Jeopardy board with all these problems in it? No, that's okay. Do you want to play the bluffing game again, or one where you, if you get it right, you get to shoot into like a basket? Shooting game or bluffing game? I think I heard more bluffing. We will bluff our way through. All right. Well, let's go. I got to count people.
You too?
Yeah, but I take it.
All right. Let's see. Right side of the room is going to be all 8 of girls. Sorry, all 7. And 4 right here. Yeah. Okay.
Over there.
With that head.
As I say, yeah.
So many support. Not even. All right. You guys don't. Well, actually, we'll go. Yes, if you catch up. All right, so you got it. Left side of the room. Yes. My left. Stand up every time, right? Oh dear. That was not my intent. You guys are right. It's me facing you, because otherwise I'll mix it up. You guys are the right. You guys are the left. All right, so everybody should be doing this, and then I'll tell you which side stands up. And if you stand up, I can call on you. Yeah, I didn't actually give you directions. Do you guys know what to do? R, S, and T. Write it in with the R's, S's, and T's only, okay? I mean, you can have coefficients, but. So R is ln of 2, S is ln of 3, T is ln of 5, and you are then using those for natural log of 4 times root 15. You ready, guys? All right, let's do left side first. Stand up if you think you know it or you want me to count you as a point. Left side. 1, 2. You're like half a point better. 2, 3, 4. Only 5. No? That's all? You need a second? Are you close? Ethan's just quitting on me here?
Yeah.
What? These two don't exactly count because they missed the whole lesson, so that's why you. No. I mean, you volunteered that you don't count, so. Okay, so 5 points. Let's see, Rohan, what you got?
2R plus root X plus T. Oh, wait.
No. Stealable. Let's see. Elijah, you want to do it? Yes. You're on the right track. You just can't leave the square root in there. Okay.
I got it.
All right. Does that make sense? The separating it? You guys just forgot the square root means 1/2. So this is really. Oh, that's 2 squared, right? So 2R plus 1/2 S plus 1/2 T, right? You could say 2R plus 1/2 S plus T. I would have taken that as well. Yeah? Is that what you mean?
Yeah.
Are you sure? All right, let's see. All right, question 2. That is a 50. Is that you, Sean? Oh my goodness. I think that's the user, not the marker. You don't have to write that like angrily. It's okay. will say you two can't stand up, but I also can't call on you, okay? A little more time here, guys. So you should be wrapping it up. All right, guys, right side. Stand up. Anybody else? 2, 3, 4, 5, 6, 9.
Oh. Three as minus 2t. Yeah.
So the parentheses, yeah, it's in parentheses, so it's right.
Put the other parentheses.
Yeah, it's right.
Wow, you could not have simplified that? Yes, you are right. You wrote it in a weird way.
Well, how is the way you
That's the more normal way.
I just want to see.
Yeah, let's go through it. How many was taking? We'll do 1, 2. Is there 8 of you up, I feel like? Okay. Let's look at. And then let's see. 5 plus 2, 5. I can say.
Yeah.
Okay. That's not your answer. Does that make sense what I'm doing? 3 cubed is 27, 50 is 5 squared times 2,
Oh, she just.
right? 25 times 2, yeah. And then square root, so the half out in front of all of it.
Yeah.
Guys, yeah, I'm not done yet. So let's see, so that'd be 3s, right? Minus 2t plus r. That's where some people thought stopping seemed like a good idea. You're not wrong. Well, you're okay. It depends on if I say simplify completely in the directions, then I would be. I'd take a little bit here. Okay, does that make sense? You guys catching on?
Yeah.
Okay. All right, let's do another one. Still with the R's, S's, and T's.
Oh.
I don't think this one will be too tough for you. Let's do. All right, we'll do.
Is that yes?
Left side, enough. 1, 2, 3, 4, 5, 6, 7. Okay. Copy.
That's 2r minus t.
Yes, 2r minus t. All right, you guys do okay with that one? Once you understand the whole decimal, write it as a fraction, it's not that bad, right?
Yes.
Anybody want me to go through that one? Some of you didn't stand up, so let's look at it. This is really 8 over 10, right? 8 tenths. I would do it as 4 over 5 because that seems easier. Nice. And then that's really 2 squared, right? Since you didn't have a 4 to work with. So 2, what was it, r? My letters. 2r minus t. Okay. All right, let's do, I think, all right, we'll do one more. We'll make it even. Let's do natural log of the cubed root of 40 over 9. It's real pretty. Let's say simplify your answer, okay? I'm going to give you guys your points when you're standing up like 6. Give a little more time, guys. Okay, I think we're on right side, right? Right side, stand up. Wow, okay, good showing here. Okay, Sean, go for it.
It's 1/3 t plus r minus 2/3 s.
Let me look at. Yes, you're right. Sorry. Can't read my handwriting. Say, did you say other? Yeah, just R in the brain. He had that. Okay. I can't use it. It's weird. Yes. Okay. Always. Somebody over here's got to write it weird.
Can you say what it was again?
Yes. Let me just go through it to make sure Everybody's okay with it? Yeah, it was, my brain wasn't processing what I said. Everybody's okay with the whole 1/3 part of it, right? 40, I'm thinking of as 8 times 5, so I'm thinking cubed, right? Plus natural log of 5. And then this is really 3 squared, so I'm doing minus 2 natural log of 3. Okay, so 1/3, and then this would be 3. I'm messing up my letters. 3r, right? Plus t minus 2s. And then if I distribute my 1/3, I get r plus 1/3 t minus 2/3 s. Okay? Yeah? Okay. You guys are winning. Nope, we're moving on. None of this is super tricky, but we'll give you guys a condensed. I don't think you're going to have trouble, but we'll see. You think you will? This is super fun to like miss the lesson and then just try to figure it out.
Yeah, the first part was interesting.
Minus 2 ln x to the power of 5 or a
3. I don't know why I put an exponent there and a coefficient, but that's okay. You can do it. Left side, you guys ready or not quite? Yeah? All right, left side, stand up. Ooh, a little more confidence here. 1, 2, 3, 4, 5. Elijah's joining the left side here. Okay, we'll give you bonus points. I think that's friendly. All right. Ethan. Just hold it up. Yeah, I'll look at it. Let's see. Yes. Yes, good. You guys got it. Natural log of x minus 3 to the 7th over x plus 3 to the 4th times x to the 6th. Okay? I don't know how many. I think you guys have fewer people anyway, so we'll just give you some bonus points. We'll make you a piece of taste. Oh,
Like just go over like this. So I got like I got it, but like I had the X on the top.
so anytime there's a negative in front, it ends up in the denominator. You can either think of it as like this is the negative exponent, or if I factor the negative outside and these two were multiplied together, they would both be in the denominator.
Okay. I just, so if you add it like this, multiply to the x squared, that I subtracted, that's why I still
Oh, okay.
That does like,
Yeah, it's actually x to the negative 6.
Oh,
Is that what you're talking about? Yeah.
all right, let's do another one. Last one.
I could say left side stand up again. So they could win. I can always change the rules. Let's do. I could None of this is very hard, guys. Alright. We'll expand this time. Ooh, no, okay, we'll do this. Sorry, change my mind. Ignore that.
You should do a hard one.
I'm trying to make a hard one, guys, but some of these are not that hard. Let's say log base 2 of x plus 3. Let's put minus 4 log base 2 of x minus 16.
Wait.
And you have to write it as a single log. Guys, this is as tricky as I can make it, okay? And it's not that bad once you see it. Once you get it, they're just not that hard. Until you get it, yeah, okay. Then we'll figure out.
Oh, I got it. I got it.
I made that really way too big, didn't I?
Yeah, you did.
Well, you don't have to evaluate it.
That's what you said.
You don't have to actually do what's 2 to the 16. All right. Bell's about to ring, guys. So what's the answer? Anybody, just say it.
Log 2 x plus 3 for 65,500.
Yeah, over 2 to the 16th x to the 4th. Yes. Guys, on your homework, it's front and back. You got these weird graphs. Skip these 3. You can't even read this graph. This is just weird stuff. So don't do these 3, okay? All right. And you have a quiz on Friday, guys. Regular quiz, okay?
We have a quiz on Friday.
A regular quiz on Friday, yes.
Put it on what? On teachers?
2526, yes.
I don't know if I've got it in the Blackboard yet.
Oh, okay. Do you know your student ID?
Yes.
Okay, here. Give me 1 second. Let me stop this.